The nervous energy of speaking is the perfect antidote for severe jet lag. So bear with me, but hopefully I'll even out. Hi. I think I have a slide to say hi. Yes, I do. Hi. I'm Potch. I am a developer advocate at Mozilla. Mozilla, you may know us from Firefox. We are a little bigger than just Firefox. We are a nonprofit organization, .org, and we actually are about protecting the internet and the web. We want to keep it healthy, open, and accessible to everyone. We don't have any shareholders. We don't have any quarterly earnings to make. The only thing we have is a mission to make the web as great as possible. And that's why we're trying to go out and tell everyone about awesome stuff that's coming to the web and a couple awesome things that are coming to Firefox in particular. And before I get started on my main topic, I'm going to run through just a few of those things that you can look forward to and some stuff that's already out there. Earlier this year, Firefox, as well as a couple other browsers, launched WebGL 2. How many of you are familiar with WebGL in general? Awesome. WebGL 2 is just an enhancement of WebGL. WebGL is the WebGL 1, or WebGL as you know it, is OpenGL ES2, and WebGL 2 is OpenGL ES3. So, just subtract 1, and you can see what the web is doing. And what that means is a bunch more features around shaders and particle physics computations and stuff that's going to make your 3D graphics that much more lush and efficient on mobile devices and desktop hardware is now possible on the web. It's pretty nice. If you're ever done OpenGL programming, it can be a little verbose, but that's why I am here today to talk to you about webVR stuff. But before that, more things. WebAssembly. Comic behind here is by my fantastic colleague, Lynn Clark. WebAssembly is a technology that sits parallel to JavaScript in your browser. So there's a JavaScript engine, and a bunch of JavaScript engines are now being bolted on this secondary piece, which is this WebVM, we call it, and it can run WebAssembly. What is WebAssembly? It is compiled binary format that can be generated by a LLVM or some other compiler, and lets you take things like C or Rust or other compiled languages and actually compile them to run at darned near native performance on the web. So what this means is, let's say you have an extremely performance-critical piece of your application, and that's such as maybe the diffing engine in React or something like that. What you could do is actually write that extremely performance-critical piece of code in C or Rust or whatever, compile it to WebAssembly, and actually call back and forth from your compiled code and into JavaScript. So it's really neat. You can actually just export WebAssembly as what looks like a JavaScript module, and you can import functions from WebAssembly modules and call them into JavaScript and vice versa. It lets you it's sort of the future of plugins, where the plugins are actually hosted in the browser and this compiled code is hosted in the browser. Tools like Unity and the Unreal Engine actually export already WebAssembly code. You can try it out in a bunch of different browsers. It's pretty cool stuff. This background slide did not load here, but that is okay. Project Quantum, I'm going to actually be speaking a little bit more in depth about this tomorrow in our little lightning talk we have at the beginning of the conference. But Project Quantum is an effort at Mozilla to completely revamp our rendering engine, which is called Gecko. Gecko has been Firefox's rendering engine since before Firefox was called Firefox. And obviously we've been keeping up with the web, but we want to make a big reinvestment to make Gecko capable on modern hardware. Computers aren't just getting bigger and bigger and faster and faster and faster like they were in the early 2000s. They're actually getting smaller and more energy efficient and more cores. And so we're actually refactoring huge pieces of the Firefox code base to take advantage of things like parallel computing, which is always kind of sketchy, and memory safety, and things that are going to let us run a lot faster. What if we computed all the styles on your web page in parallel as opposed to in a long list? Turns out style computation parallelizes as well, and you can expect about maybe a 3x speed up in style computation. We're trying to find things where, as opposed to making web developers learn amazing, cool, awesome hacks that make things a little bit faster, what if the browser engines were also trying to come up with really fantastic techniques to make existing code faster? We want to be not just telling you to make your code run faster, but making the browser faster too. That's really what Quantum's all about. I'm going to have a lot more to say about that tomorrow. This is a placeholder slide. Things to look forward to this year. We have a thing called the Tor Uplift. Tor is a privacy sort of a privacy-focused and privacy security-focused browser that lets you browse completely anonymously on the web. Tor is actually based on Firefox, and Tor has this big set of changes they apply to the Firefox code base to turn Firefox into Tor. Right now, maintaining that separate set of patches from Firefox can cause bugs, and those bugs can be exploited to break the anonymity and privacy of the Tor browser. So what we're doing is we're actually taking all the code from Tor, or as much of it as possible, and putting it in Firefox. So Firefox won't necessarily have all of Tor's features by default, but either by build configuration or by changing preferences, you can actually make Firefox into Tor. This is going to make Tor more stable and give a bunch of awesome new privacy and stability features to Firefox. We're having strong sandboxing and multiprocessing in all platforms this year. For the longest time, Firefox has not been a multiprocess browser, and we are fixing that. We've already fixed it in most places, and we're going to go full multiprocess by, I think, the end of June. So very, very soon. This allows us to make a bunch more security guarantees and also make sure that a background tab is not going to slow down your foreground tab. We have a couple cool experiments called in a system we have called Test Pilot. Test Pilot is an extension you install in your browser that actually lets us deliver you prototype browser features. Things like screenshots, where if you take a screenshot of a web page, not only does it take a picture, but it records all the DOM underneath, and you can search all the text that was in that screenshot. Which is really cool. All kinds of things like tabs on the side, all sorts of user interface and feature work. We're actually letting users try out in piecemeal and then give us feedback and say, oh, I liked this, oh, this is a little weird. And then eventually a lot of those things graduate from Test Pilot and actually become real Firefox features. So you can try out Test Pilot, it's really nice. And we have a project called Web Extensions. How many of you have written a browser extension? How many of you have used a browser extension? Yeah, right now, browser extensions are not a whole lot like web pages in the sense that right now you have to write kind of a different piece of code for every individual browser. We think that's pretty weird because the web is really all about sort of cross-compatible standards. So we are adopting and adapting the Chrome extension model, which is actually pretty darn good and looks a lot like writing things for the web. And Firefox and Edge actually now support a common subset of extension APIs with Chrome. So you can write one code base and support multiple browsers extensions without having to maintain weird, incompatible pieces of code. Very cool. I think we have almost entirely Chrome parity as I stand here, which is really rad. So if you maintain an extension, you should try to run it in Firefox because it probably just works. And then you can just say, yes, I want this in the add-ons marketplace. Other major things to look forward to, WebGL2 and WebAssembly I mentioned, webVR I'm going to be talking about, and CSS Grid. If you haven't played with CSS Grid, you're going to be hearing a bunch about it from Rachel Andrew at the event. I'm going to jump to a couple other things you can do. If you like what I'm talking about here today, you can get involved. You can contribute to Mozilla's many code bases, the big one being Firefox, but we maintain all kinds of projects. You can participate in our various internship programs. We have traditional internships for sort of university students, and we have programs like Outreachy, which seeks to provide opportunities for underrepresented groups. You don't have to be a student for this. It's a whole different program. We are part of the Outreachy program, and you can find out how to join that. We have a bunch of stuff, including around webVR. We're sort of pre-packaged curriculums, where if you we call it a campus club, but if you want to get a group of people together, your meetup, and say, hey, we're going to build an extension or build a webVR thing tonight. We have prepackaged curriculums and tutorials you can use to run your events, and we're hiring. So if you want to join us, you can click out there. Ooh, geez. This is what happens when conference Wi-Fi rears its head against Google Slides tonight. So I'm going to skip right from that webVR slide to this webVR slide. I think underneath all of your seats is a pair of red and blue 3D glasses. I am kidding. But this used to be how we did 3D graphics on screens. We've come a long way. But yeah, my talk is browsers in the third dimension. So how do we get to the third dimension? How did we get to the second dimension? Yeah, that's why I said I work for Mozilla. And Mozilla was not the beginning of the tale that led to VR on the web. Actually, and this is the future of VR on the web, by the way. You'll all be sitting in this room together, but wearing masks and not being able to see each other. It's going to be great. Just kidding. In the beginning, there was Safari. Safari, people love to hate on Safari, but they do a lot of cool pioneering work. And in 2004, they did a great bit of pioneering work called the canvas element. Safari wanted to draw on the web, and they did not ask permission. They just made an element called Canvas. And Canvas sort of looks a lot like a drawing API like you'd find in processing or in Apple's Quartz rendering system. And they made one really smart decision when they made Canvas, something that I think really helped adoption and standardization. When you grabbed a reference to something to start drawing, you said get context, and then you said what kind of context you wanted. And I thought this was pretty prescient, right? You're like, hey, I want a two-dimensional drawing context. As opposed to saying Canvas is for 2D drawing, they said, oh, maybe that's not the only kind of drawing we'll have. And that's actually pretty smart future-proofing on Apple's part, and we sort of built off of all of that. Because if you have 2D, then why can't you have 3D? And it turns out that you can have 3D, we just call it WebGL. So what we end up doing is saying, oh, we have this rectangle that you can make, this element that makes a nice rectangle, and you can draw arbitrary things into this rectangle. And normally we use these little Canvas drawing commands, line 2 and arc 2 and fill and stroke. But what if you could use the OpenGL APIs to draw into that rectangle? That's precisely what WebGL is. WebGL is actually, like I said, is a product of the Kronos group, who also makes OpenGL. OpenGL you'll recognize from literally every 3D graphics platform that you've ever seen before, except for on Windows. And even on Windows, OpenGL is everywhere. It's a great open, standardized set of 3D drawing primitives. Pretty much, even a lot of 2D drawing on your devices is actually being done with OpenGL, just because it's efficient, and it's fast, and it's there. So the web takes advantage of the existence of OpenGL and actually wraps up a subset of that into WebGL. So this is going to be another conference Wi-Fi test here. I have a couple slides here that are load live. We'll see if we oh, there it was. Look at that. Just as I gave up. Okay, you can see that WebGL is pretty widely supported at this point. Most notably, it is supported in Safari these days, which is a relatively new addition. But if you make 3D graphics on the web, you can now more or less get them everywhere. This is also going to take a second to load. I just love this demo. There's a bunch of websites that just let people, they say, here's a canvas, make the coolest graphics you can using only 3D shaders. You're not allowed to use any drawing primitives. You just make shaders, and those shaders draw on the screen. That site is called Shader Toy. Let's see if I can test the fate of the Wi-Fi gods again by seeing if this will load right as I hit escape. Maybe I'll turn off my VPN. We can have all kinds of luck here. That's okay. We'll jump straight to the cube. So look at this. Behold, this is everything you can do with 3D on the web. That's it. No, it's not. But this is one of the most basic things you can do with 3D on the web. And how do you do this unbelievably simple thing? We made a cube, we put some colors on the sides, and we're spinning it. There's not even really lighting and shadows here. It's just, if a face is visible, draw this full color. So what's that code look like? I'm not actually going to read all this. I'm just going to show you. So okay, we get a canvas. We get the WebGL context of that canvas, and then let's see, we define some vertices, and we define some colors for those vertices, and then we define some indices. Then we create a vertex buffer, and we say there's a type array, and we create a color buffer, and then we create an index buffer, and then we actually load a bunch of fragment code, which is not included in this code, and we create shaders from those fragment code, and then we create a shader program, and then we create a bunch of matrices, then we bind those matrices to our geometry, and then we get the projection from our camera, and then we do some matrix calculations, and then we move that around in space, and then we rotate if we want to, and then every frame we refigure out, this is actually figuring out the size of our screen, but then every frame we figure out what we have to draw, and we take all those matrices and apply them, and then finally we have an animating cube. Simple. Oh, right, and then here's the code for the shaders, right? So we have this language that isn't even JavaScript now, that looks kind of more like C. We define these matrices, and we do calculations for every pixel and every fragment. Couldn't be easier. I expect you all were writing that down. Great. Fortunately, people have taken this really complex low-level API and wrapped it up. One of the more notable examples is 3JS. Hey, look, it's our cube again. So what does the code for the cube look like if you're using a sort of modern 3D framework? I mean, obviously, it can only get so abstract. But so now we create a scene, and we put a camera in our scene, and we create a renderer using WebGL. We do a little bit of administrivia here, and then we create a box, And then we say different colors for each side of the box, and we turn that, and we make this box into a material. We add it to a cube. We make a mesh, so we've got a little cube here. And then every frame, we rotate the cube, and we draw it. That's a lot less code already. It still involves a fair amount of arcane things. We're still kind of dancing around these notions of, matrices and things like that. What if I don't know JavaScript and I want to make a cube? Can I do it? Okay, so I'm going to talk to you a little bit about A-Frame tonight. A-Frame is a framework built by the Mozilla VR team to make it really, really easy for anyone to make a 3D and a VR scene, even if they don't necessarily know any JavaScript. Obviously, if you do know JavaScript, you can peel back the hood and do much, much more powerful things than just a cube. But let's see, what does a cube look like in A-Frame? My scroll, there's no scroll bar. Cool. All right, so what do we have here? We have a scene, literally called a scene. We have a cube, which has a color, and we get some default lighting. We have an animation, and that animation is going to rotate my cube to these angles over 10 seconds over a constant linear thing, and we're going to do that forever. And we have a sky in the background that's gray. That's it. So how do we go all the way from this code to this code? And in fact, just for people who aren't necessarily familiar, how do we even use these fake HTML tags? So yeah, A-Frame is this framework built that wraps 3JS using web components. How many of you know about web components? It's year 2017, probably more people than they used to. Web components is a set of standards that allows developers to define their own HTML elements. And it's supported by a number of browsers. In particular, the part we're referring to here is custom elements. What this means is I can tell the browser, I load some JavaScript, and that JavaScript says, I want to make an element called a cube. And I'm going to explain to you how the a cube element works. When I change this attribute, I want you to do the following thing. It's really great. It makes it possible to really package up widgets, especially UI widgets or visual widgets, in great little bundles where you can just reuse them and say anyone who wants an element called a cube can have it, and they can drop it in their web page. Web components are cool. I encourage you to learn more about them. How A-Frame is using them is when you actually do something like a scene, underneath the hood, we've created a WebGL context, and we're creating a 3JS scene. So when you create a cube, we're actually going in there and making stuff for you. It's really just custom element wrappers over 3JS. What this means is if you have A-Frame on a page, you can use the web components to make a basic scene, and if you know some JavaScript, you can reach beneath and start messing with the 3JS objects directly and do a lot more powerful stuff. So you have a cube. What is a cube? A cube is actually some box geometry and a mesh material. This is just a way of describing the color and appearance and lighting. And then we create a mesh out of those two things, and that's what we draw to the screen. But you didn't have to know that. You just had to know a cube. So yeah, A-Frame is actually built on top of custom elements, and custom elements are actually using to talk to 3JS. And 3JS can talk to WebGL for 3D graphics, but it can also talk to webVR and the Gamepad API. I would just like to ask, how many of you knew that your browser had a Gamepad API? It's been around for about 5 years. Isn't that wild? It's one of the less known things out there. But what that means is if you plug like a USB gamepad into your computer, JavaScript pages can detect that and start reading the buttons and joysticks off it. It's really cool. You can use it to make games. You can plug an Xbox controller into your computer and play web games. It's really fantastic. No one knows about it. But hopefully you will learn a little more about it tonight. So webVR is one of the newer on the block, or newer standards on the block. There's a couple little awesome little microsites that talk about WebVR. This is WebVR Rocks. Explains what's going on here. WebVR is a JavaScript API for creating immersive 3D VR experiences in the browser. Who supports it? A surprising number of people are starting to support WebVR. Different browsers kind of support their own proprietary and a bunch of open things. So Microsoft supports Windows Mixed Reality, obviously. We don't have a proprietary platform, but we support the HTC Vive, which I've got right down here, and the Oculus Rift on Windows right now. We're hoping to expand both platform support across the board, and we're actually working on Google Daydream support, the Google Daydream standalone VR headsets. Chrome actually supports their Daydream headset and the Google Cardboard you haven't seen one of those before. There's one down here somewhere, maybe, oh, right in front of me. Just this takes your cell phone and lets you kind of start playing around with a little 3D experience that you can actually see in 3 dimensions. And then if you actually download special builds of the Chromium browser, you can actually get support for Daydream, Cardboard, the Vive, and Oculus. So this is not in Chrome normally, but there are special builds of Chrome that are compiled with support for all kinds of headsets, including ones that let you walk around in a room. It's very neat. Samsung, the browser, supports the Samsung VR, obviously, but it also supports the Cardboard. Oculus actually supports the Samsung Gear VR, surprisingly. And they're working on, I think, support for a couple other things. This is the Oculus browser. And we have an experimental browser called Servo, and right now that has support for the HTC Vive, just sort of as a test bed for us to have multiple platforms to play around with. So how are we doing, how do you do VR in a browser? How do you, create 2 pictures, for each eye? It's really just about double vision. We're just tricking your eyes into thinking you're seeing 2 different things. This is the oldest 3D trick, right? We show each eye a slightly different picture that looks like it's from a slightly different place, and your brain says, oh, hey, I'm here now. It's amazing how easily we're tricked, but the trick is actually very simple. So it's not really double vision, it's binocular vision. It's the same trick, you use it looking through binoculars. So here's a little 3JS scene, and you can see right now there's a rectangle, and we're drawing one picture into it through one camera. We're looking at that scene through one camera. Well, inside of a VR headset, it's actually just one big screen and some lenses that focus your eye on a different part of the screen. So really, the trick to doing VR on the web is just making a canvas and drawing one eye's view into one half and the other eye's view into the other half. And then instead of drawing it on your laptop screen, drawing it down here. That's it. That's the core trick. In addition, we then ask the headset, hey, where are you and where are you looking? And all the sensors in the headset, every frame, tell you, I'm currently here, and I'm looking that way. And we just take that information and give it to our WebGL code, and it goes, oh, I'll draw as if someone was standing there. And if you do that 90 times a second, you've created an immersive experience. There's not actually a whole lot of voodoo here. It's no different than drawing on a laptop screen. The only difference is we have a bunch of extra lenses and sensors attached on our headset. If you're using a Cardboard, we're actually just using the gyroscopes in the Cardboard, in your phone. So what does that look like? There's actually an API in the browser called navigator.getVRDisplays. This used to have a different name in the version 1 of the webVR spec. We're now on version 1.1. The naming has gotten a little cleaned up, sort of in preparation for more expansive capabilities. But you say, hey, are there any VR displays connected to my computer? And if there are, you get a list back. And you can flip through there and say, oh, I'm made of money, and I have an HTC Vive and an Oculus Rift and a Daydream, all connected to the same computer, and a wireless Rift and an experimental piece of headset. I only want that one. That doesn't usually happen. Most people have one VR device connected to their computer, and that's the one they use. But this way, it lets you detect the devices connected and then start talking to them. One of the most important things you need to learn to trick your eyes is how far apart they are. If you've ever gone to an eye doctor to get your prescription, there's actually 2 pieces of information in the prescription. How strong the lenses are and how far apart your eyes are, because that lets the person making your glasses know where to put the center point of the lenses. Nice VR headsets actually have adjustments that let you take the lenses and move them side to side to let you line up the center of the lenses exactly with the center of your eyes. That means there's not going to be any distortion when you're looking at the scene, and webVR takes the exact same information. So when you request VR displays, you get these objects back called VR display. And one of the things that's in VR display is your eye distance. So you can actually read from the display. The display says, right now, the eyes are set this exactly far apart. And you can get the offset for your left eye and for your right eye. And using that information, you can create virtual cameras in your WebGL space and put them at the exact right distance so the user doesn't feel like their eyes are too far apart or close together, which is a very uncomfortable sensation, though it's not one you're used to. If you have something like the Vive that has motion controls, which means you can actually use your hands in the experience, how do you connect that to a web page? As opposed to adding a whole new API, we actually extended the Gamepad API, which has already been there, to add new information to gamepads that support it. So if I have a Vive controller like this, and it's being tracked in space like this one, it's actually going to have extra information attached to it. This isn't just a normal, Xbox controller with buttons and joysticks. It actually has something called a pose. And a pose is a combination of where it is in space and how it's oriented. And for every gamepad you detect, you can actually say, you can see right here, I'm getting the gamepads and I'm filtering them by whether they exist because of a fun bug, and then if they exist, whether they have a pose. And if they have that pose, we can then gather position information, which is a vector in space, and orientation information, which is an annoying, mathematical concept called a quaternion that makes it really easy to rotate things around in space, but makes the math a little more mind-bending. Fortunately, there are lots of libraries out there to support that. The 3JS, in addition to just doing standard, in addition to just making WebGL easier, actually has a thing called a VR effect, where you pass it all this information, like the eyes are this fall apart and the person's this tall, and their eyes are actually this far from their neck. So when I move my neck, the camera actually tilts forward as opposed to just spinning. And it takes all that information and you give it an existing 3D scene, and it automatically creates 2 viewports and splits a canvas in half and draws 2 eyes. So all this stuff is kind of being done for you by some pretty nice libraries that are out there. A-Frame, however, builds on top of all those VR concepts and 3D concepts. So if you really want to get started with A-Frame, you can just start using these HTML primitives. The default set of primitives is pretty extensive, but also somewhat limited, right? We can make a box, we can make a camera, we can make a circle, we can make a sphere, we can make a cone, we can make a curved image. This is nice. You can take a JPEG and just kind of wrap it around one axis, or a spherical axis, and sort of put a nice little arc out in front of you. It's great for UI. You can make a dodecahedron because they're pretty. You can import models. There's a format called GLTF that if you have something in a 3D modeling program, you can import that whole model into your VR scene and just kind of put it in space and rotate it and move it around. And you can take images, you can make skyboxes, all kinds of things. If you have a video shot with a cool 360 video camera, you can say a video sphere and give it the URL of that video, and now you have a video that's wrapped around your head that you can look around. So actually a bunch of media sites, including the New York Times and Al Jazeera, are actually using A-Frame on their websites in production to take spherical video content and let you sort of visit the scene of the news, and using your cardboard or a more advanced headset, actually just look around and say, hey, I'm currently in this major event. It's pretty cool. It makes it really easy. All they need to do is record video and provide it to a very, very small piece of JavaScript code. But what if you need more power? What if this limited set of primitives isn't enough for you? Well, it turns out that all of these primitives are actually built on top of a more powerful system. It's called the entity component system. If any of you have ever done game development, you may be familiar with the concept of entity components. There are things, for instance, a torus knot, that are actually made of underlying principles. So for instance, you have a sphere. What's actually happening in A-Frame is it's making an entity with the geometry of a sphere and passing through the radius to that, and then creating a material that has this coloring color. So we're actually just taking a bunch of lower level concepts and piecing them together. What this means is that you're not limited to this set of primitives. Really, really easily you can build all new sets of primitives and share them with other people, because they're not very big snippets of code, or start using the entities and components directly. So for instance, here's the list of components. You can see it's a much sort of mealier and lower level set of things, but we've got geometries and materials, and we've got HTC Vive controls, and we've got WASD controls, meaning you can just take an object in A-Frame and say, I want to be able to move this around with the keyboard. And you just stick WASD controls on it, and now when you press WASD, that moves. That's all you have to do. Or we have look controls or Oculus Touch controls. Look controls mean, let's say I just have a cardboard viewer, and I want to be able to move around. I can actually just look in a direction and push the one button, and it will move me in that direction. It's the simplest possible way to move around, but it does work pretty well for limited experiences. All kinds of things that sort of enhance the baseline set of materials, and in fact actually are the way we define the baseline set of primitives. So you can do all kinds of wild stuff with this. Fabian's actually going to show you a bunch of those things, so I'm not going to quite spoil it. But as I said, we support the Oculus, we support the Vive, webVR supports Daydream. This is relatively new, but pretty cool. So if you have an Android device, you can actually start playing with this stuff in Chrome for Android. And we support just your phone. Most people don't own a VR headset, but they do own a smartphone. So we're going to do a quick fun game. Everyone who wants to can take their cell phone out real quick and go to aframe with no dash.io. If you go to aframe.io on your phone, what it's going to do is start reading the gyroscope on your phone and show you just a really basic little scene. And if you hold up your phone and just start looking around, you're going to see that even without a cardboard viewer, A-Frame actually has a responsive VR experience. This means if you open up this experience on your desktop, which I'm about to do, you'll actually be able to look around, but by clicking and dragging with your mouse. If you, conference Wi-Fi and slash, I know it's a little slow, but so we can go all the way from, with the same piece of little code where you defined a really simple scene, I can go all the way from click and drag on my computer to look around on my phone in 3 dimensions, and then if I have a cardboard viewer, push that little VR button that pops up on your phone. You probably can't see it yet because it hasn't loaded here. There's a little VR headset button, and that will actually take you into VR, which right now is monocular because I don't have a headset connected. If I did, it would split into 2 eyes. Your phone actually may split into 2 eyes if you push the button. And if you have a Vive connected, it's going to figure that out. And as opposed to just letting you look around, you're going to be able to walk around. So with the same set of code, A-Frame is taking care of detecting what your browser and what your user experience is capable of and scaling up from clicking and dragging all the way up to, you have to cross your eyes to get the right effect in VR, all the way up to being able to walk around and interact with things with your hands. So it's really great for building responsive VR experiences, and it's really sort of out there on the bleeding edge of some of this stuff. Oh, and here's an example of those keyboard controls. So you can see I can do that and click and drag and walk. It's pretty fun, even with just a simple cube. Like I said, you can get started with the Oculus with your phone, or with the cardboard with your phone. We have a couple cardboards sitting around here if people want to test some of that stuff out tonight. But actually, I want to jump to the exciting part, which is the demos. We're actually going to be setting up an HTC Vive right here. And if you all get refreshments, but not too many beers, you can try on the HTC Vive and actually participate in a couple of our demos. And before we get started, Fabian's going to show a couple of those demos off. But we have a little stage pegged out here, and we have the HTC Vive sensors set up. So I'm going to wrap up the rest of my talk, and then we're actually going to let you get some refreshments, and then we're going to be showing off some awesome VR demos. So this is a Drupal conference. So I wanted to quickly touch upon some stuff you can do with Drupal and webVR, because there's already some integrations available. Someone may be aware of this earlier this week. There's actually a Drupal module for A-Frame. This makes A-Frame primitives actually available in Drupal as Drupal entities. So you can actually, if you're laying out display suite or view modes, you can actually pull in some A-Frame elements in defining the actual visual aspects. In addition, you can set an A-Frame scene as a display suite mode. It's pretty cool. It just makes things a little bit easier to jump from just content in your database to a virtual reality scene. There's also a module called Drupal VR, which is a little bit more experimental and strives to support sort of a more soup to nuts experience. It actually adds the ability to edit webVR scenes into the Drupal CMS. This is pretty out there, and the support is not all the way baked. However, it's a really cool module. I'm fascinated by what this might allow. Might let people actually, with a no coding experience, build a basic VR scene through the Drupal CMS, which I think is fantastic. So one more thing. If any of you were watching announcements from Google I/O, they actually started talking about something called webAR. And this is the notion of augmented reality. In addition, Microsoft is talking about webAR in context of their project, the HoloLens. So as opposed to having a mask that obscures your view of the world and presents you an alternate, you're actually looking through a set of lenses or optics or a camera that, as opposed to, that lets you see your world and adds new information over top of it or integrates it inline. So WebAR is really, really early days, but we're actually going to be potentially extending the WebVR standards or building new ones to let you, as opposed to just say, I have a world with a box and a sphere, isn't that cool? To saying, behind that chair over there is like a treasure chest. You can walk over there, and if you look behind the chair, you can see it, and the chair will actually obscure it, and you can actually anchor virtual objects into physical space. It's super cool, but it's very, very, very early stages. I don't even have a demo to show you. So that is the contents of my talk. We're gonna get started into demos, but real quick, I wanted to answer questions from the audience about anything that I had to say just now, any questions about Mozilla stuff in general. And if you do have a question, I have an adorable plush fox to give you. So any questions? Not to cede the audience any. Yes, go ahead. You have a mic coming your way.
I really want the fox, so I'm going to just make one question. How did you solve the issue with navigation or movement with, with VR when using your phone? I mean, you need an extra, device to move around, not only to look around.
Absolutely. Right now, the biggest solution is actually found in Project Daydream, which is Google's sort of phone-based VR headset. It's kind of cardboard plus. And what they're doing is they're actually letting the phone speak to a sort of small handheld controller that has a little bit of gesture support and a little joypad on it that lets you move around. Other things we're doing is there's actually a bunch of new cell phones that are launching with what's called Project Tango. I believe Google rebranded it to WorldSense. What that means is your phone can go into a mode where it's using its camera and a couple other sensors to, in real time, build a 3D model of your space around you. And that means if you take a step, it actually knows that you've moved in space. So what's cool about that is you won't even need these little lighthouses anymore. You'll actually be able to just turn in a circle and it'll go, yeah, I built a close enough model of the room you're in, and now if you take a step, this device has Project Tango on it. I can't give it away. I can give the foxes away. And what that means is you don't even need a position sensor. You can actually just, the technical term is it performs SLAM, simultaneous localization and mapping. What that means is it's constantly building a model of your world and placing you in it, using whatever data it has. It's very cool. I imagine we're going to go in that direction very, very quickly, just because, I think even HTC, the new headset they announced at Google I/O, doesn't need the lighthouses. They're already moving away. This is sort of a transitional thing. So right now, we're moving. We have this position sensors, and we have these little joypads, but we're going to get the ability to just say, do smart math and let me walk around my room.
Thank you.
Yeah. Oh, a little short. Please. Oh, you have a mic. Sorry, you have a microphone coming. My apologies.
Thanks, Mike. So with the web, there's always been somewhat of a gap between native APIs as to what devices support natively and what the browsers support.
Yes.
Is there an equivalent gap? Like, I'm completely unfamiliar with VR, but I assume that there's some sort of a gap between what native can do and what the browsers can do.
Yes.
What does that look like? What is the gap?
The two big gaps are one, we are limited to. There you go. One, we are limited to WebGL in what we can render. WebGL, as I said, is OpenGL ES3, which means it is not all of OpenGL. It's sort of the limited subset that's designed for mobile, which means there are some OpenGL features and some latest generation shaders and fragment renders and things like that we don't have access to. Now, that's probably okay in the short term because VR is a complex enough thing that when you're doing the absolute highest end 3D, you can't produce frames fast enough, even on beefy hardware, because you have to produce twice as many all the time. So right now, the limitations of sort of WebGL we're not bumping into them, but I suspect we're going to pretty quickly. Another thing is if you want to do computation for a VR experience, we're kind of limited to single-threaded JavaScript right now, which means on native hardware, a lot of times you could actually do parallel processing to do all the critical stuff in the background, and that way you make sure you're never dropping a frame or adding latency to the view. The web is starting to get the ability to do multi-threading and things like that, but we're not there yet. So definitely, I'm going to get out of the way so the sensors, but definitely another downside sort of the web versus native is the ability to do parallel code and multi-threading. It's lagging. I wouldn't say it's permanently behind. But yeah, and otherwise, right now we have WebAssembly, but WebAssembly is coming. It's it's available in a couple browsers, but in other browsers, you don't have WebAssembly, which means you have to build your VR experiences in pure JavaScript. This is, for the most part, okay, but you have things like GC pauses and things that can mess with experiences. I would actually say that VR is a pretty good example of the web being very, very fast to keep up with native. We're trying not to get burnt the way we did with mobile in general, but obviously, non-mobile web stuff has access to, or non-web stuff has access to everything in your hardware, and otherwise, we have to wait for browsers to define APIs to allow pass-through. But we're doing pretty well. Other questions about WebVR, Mozilla stuff? Back there, I see a question. These are very light. I don't think I'm going to be able to throw it that far.
Hello? Testing? Okay.
Yes.
I'm just doing that for the plushie, so... Okay.
Well, ask the question first.
Okay. We have the video sphere element, which is just the 360 video layered on the inside of a sphere.
That's
am I
correct.
Right? Okay. I think the future of 360 video in general is to give a more 3D experience, immersive. Do you have an idea how this is gonna get implemented?
I have a couple thoughts. A lot of the work that's being done already around more immersive video is really about video adaptivity. So what you do is you record a ton more video than it seems like you're going to need from usually with a bunch of cameras, and you extract 3D information. And then what happens in the current approaches is if a user's looking in a certain direction, you actually process the video to give them a slightly different stereo view. That we're already doing that with two-dimensional stereo video. Sort of Facebook is, I think, doing some early work with this sort of thing.
Yeah.
The same approach is going to work in 3JS, because 3JS video spheres, one of the things you can apply to them is a material that's driven by a real video element. So all of the approaches we're already doing with adaptive video around 360 video and the beginnings of 3D video are going to apply immediately. So I think it's mostly a problem of video processing and adaptive streaming. Facebook's come up with some really clever stuff of they actually use they hacked adaptive bitrate streaming to, as opposed to saying we're going to show someone a different stream based on what speed their connection is, they say we're going to show you a different stream based on which way you're looking. Yeah. And by doing that, they can actually have server farms full of preprocessed video for 1 degree in every direction you're looking, and serve you a different one, or do real-time processing on device to take a much larger data set and compress it down to stereo video. But those approaches are going to apply to the video sphere stuff directly. But yeah, it's an order of magnitude more information already.
Okay. But webVR as a standard is going to be future-proof.
Well, because this is all really just about the video content itself, the webVR API is really just about how do I take that video content and wrap it around your head. So most of the research is actually being done in how do you make the video content, and that's going to be directly applicable using webVR. WebVR is really a bunch of little nuts and bolts. It's screen discovery, it's position sensing, it's controller interacting, and everything else is already the web. So if a video element can do compelling stereo video that changes as you move your head, then we can use that already. Oh, nice. Fabian's doing some painting. Nice.
Okay, thank you.
Yeah,
Good
sure.
flashing.
No way. Too light. And a terrible arm. Other questions?
Pretty close.
Can you pass that back? Other questions in the room? If not, you can continue to ask me questions with the benefit of some snacks and beer in your hand, and I can let you all go to get, I believe the catering is here. Is that correct?
Yes.
Oh, so I will not constrain you any further. Thank you so much. I'm going to be here. We're going to be giving VR demos and plushies. I'll keep giving out plushies for awesome questions if you come up to me. But please help yourself to some refreshments, and we're going to be doing demos and hanging out for a little while longer. So thank you. HTC now sells position sensors that aren't even attached to a hand controller. So they're just these little tiny like sensors that you can put them all around. So we could actually, if we had like a chair in the corner, we could put position sensors on the chair. So if you moved the chair, a virtual chair could move. The tracking on these is so precise that people can actually, wearing the mask, can actually juggle the controllers and catch them, because the tracking is precise enough. They know exactly where they need to put their hand. It's very strange when you put on the headset and someone goes to hand you a controller and you can see it and you can just like grab it and it's exactly where you think it will be. So I'd be concerned that bouncing stuff off Wi-Fi through your phone would be a little bit shaky. Is there a gain adjust on this? Just a little bit feedbacky. Other questions while people are waiting to demo? Sure. So you're asking, the question was,
What are the processing limitations?
the processing limitations right now are, I can repeat the question. Yes, what are the processing limitations of the web stuff, the web sort of APIs, is that correct?
Yes, yes.
Right now, there's not really, the biggest processing limitation we have for the web is RAM. So how many things can we hold in memory? You're kind of using, right now for the most part, VR is using the browser's pool of RAM for your experience. So if you have a bunch of tabs open, you're using the same pool. And this is on a 64-bit computer, no problem. On a 32-bit computer, you can actually really easily build a VR experience that's going to completely blow up your RAM and make your browser go out of memory. Fortunately, we're moving almost entirely to 64-bit stuff. So it's not going to be as much of an issue, but it is a big challenge in a browser versus a normal application to find a block of memory, contiguous memory big enough to say, hey, move this big block of memory in and out of the GPU.
Yeah, I was thinking about the phones and the IoT, if they would work on the future.
Yeah, I
mean,
I'm going to guess that in the future, everything is going to get better and faster, but I don't know any concrete information. I just know that I expect devices are going to get more capable, but we're also going to find a bigger variety of devices. Next person want to come on up? I think you were ready?
Just a quick comment.
Yeah, sorry.
Just a quick comment about limitations. Like the more you have access to 3GS and then to WebGL. So if you really want something heavy and complicated, you can go down to shaders and get something really efficient, including physics, because you can do your processing, your distributed processing on it. So, I mean, of course, there are limitations, but if you really want to do something visually impressive, not so much limitations.
Thank you.
Thanks. Other questions floating around here? Would you like a blush? A little short. I'm professionally short this evening. We'll blame the jet lag. Not used to being this far south. Oh, I will be publishing the slides later this evening, and I will tweet at the Frontend United conference and use the hashtag so you can find them. They're all web-based, so you'll be able to find those slides. Thank you. That counts. Other questions? I may go wander to grab a little bit of refreshment, and people can catch me out there as well. HTTP 2, I think, will have a big impact. One of the things that some of our more advanced demos are already having to concern themselves with is asset streaming. And HTTP 2 is right in the pocket there, being able to push assets sort of on demand over an open connection. It's going to make it way easier to build much larger experiences and not have to worry about, you either putting on your mask and sitting there in a loading screen, or you not even be able to put it on your mask because it won't even go into VR until the loading screen is done. A lot of existing experiences have that limitation, and HTTP 2 is going to really break that, I think, because we'll be able to say, oh, as we move on to the next zone, just start streaming in new assets.
This seems to me like would be a big game changer in e-learning.
Yes. So the question was, there was a comment. This can be a big game changer for e-learning, and it already has. We actually, the VR team and myself, we did a small collaboration with a local school in the Bay Area where they were doing a unit on space exploration. And we actually had a VR experience about working on a mission to Mars. And you had to solve, in sort of people would, as teams, one person would be in the headset and we'd sort of have people in mission control helping them repair a rover and, adjust the antennas on stuff. So they were, had the headset on and they're actually they're in Mars. We can't see what they're doing, but we have like informational stuff. When we say, oh, you need to adjust the antenna. And it's sort of just a real neat way to have a shared experience. Obviously, it would even be cooler if you could have two headsets going in the same time. But no, being able to sort of, the transportational or the transporting effect has big impacts in learning. We've already, schools are very excited about this stuff, including A-Frame, because with some cheap Android devices and a couple pieces of literal cardboard, classrooms can even start playing around with VR, which I think is a pretty cool trick for the 21st century to have schools have VR. The question was, what about offline? You have a plush already, I think, don't you? However, it's a good question. It's a completely valid question. Fantastic. The question was, what about offline? The answer is, anything you would do to make a great web experience offline, you should do. So what that, in concrete terms, I'm going to highly encourage people to look at. Oh, do we have a? Fabian wants. Did Fabian wander off? Oh, hey Fabian, we went a little squirrely. I think we have to fix it. Is it supposed to be two eyes like that? Oh, it's okay. Cool. Things like service worker for offline caching apply just like this, right? We have a bunch of resource URLs of models and graphics and stuff like that. You're going to get huge performance benefits if you're using things like service workers to keep a bunch of that information offline, including if you're building multi-zone experiences, being able to do the navigation even offline. So yeah, the cool thing about the webVR is it's VR on the web, which is great because that means all the cool stuff you already know about building a good experience on the web applies. So definitely service workers for asset caching are highly recommended for making some of this stuff work well offline. Yes, that's the question was, are there any limitations on size? And yes, Service Worker has a much, much larger cache available to it than, for instance, local storage or IndexedDB. However, there are limitations. For the most part, they're pretty hard capped. There are things like the quota API where you can ask the user permission. You can say, hey, you meant to install this. Maybe you added it to home screen. And either we can treat that as an implicit signal on the browser's part that you would like that to have more access to space, or that you can actually explicitly prompt the user and say, hey, I'm going to need to store 2 gigabytes of information on your computer. And let you ask permission. And then the user can be like, yeah, that's fine. And then much like you would download an app, have access to a much larger block of storage. But it is a much more tenuous dance because the size of some of this stuff. Painter and these things are not quite so big, but things like 3D video, it's you thought 4K was bad. It's 4K times 16. It's a lot of data.
Progressive enhancement based on hardware capability.
So it's actually not so bad. For instance, A-Frame out of the box does progressive enhancement based on hardware capabilities. We start with, oh, you have a screen and a mouse, you can click and drag. Oh, you have a screen, there's a gyroscope available. We can just let you do 360, but not binocular. Oh, you have a cardboard. You can split the screen and drop it in the cardboard. Oh, that cardboard is actually a daydream. You can use the Gamepad API, the already standard web API to discover that VR gamepad and use it. Oh, you have more than one gamepad. You can discover more than one gamepad and sort of learn that this is the left hand and this is the right hand. So we have this great, and then also, the head-mounted display is giving me both a rotational piece of information and it's giving me a piece of positional information. That means I must have a room scale system or a Tango project or something like that where I actually have positional sensors. And you can just like the way you would say, oh, does this property exist on this object? You could say if dot position is on this VR object, I now know that I can position it in space. So you can really scale up an experience, and A-Frame helps you with that, but the native experience of discovering the capabilities, The good news is this was built in the last 5 years, which means a lot of the lessons learned about progressive enhancement and capability testing are out there, and they all sort of apply pretty well.
What about things like scaling down the texture at the level of detail on text?
Yeah, that's good. You can, not really based on processing power. We do have the ability, you do have the ability to ask the VR display, what's your resolution? Or what's your resolution per eye? And use that information to make better texture decisions. You can even say, hey, what's your field of view? And then all the old school 3D tricks always apply, right? Use fog. turn down texture data. That's a smidge loud, but not just painting. This is all the demos we've showing you are turn that volume. There you go. All the demos we're showing you are actually built using A-frame. So obviously we're not using a cube and a sphere here. We're using far more advanced, but we're actually taking advantage of that same entity component system to build, VR games and VR sort of fun little toys for painting and dancing. And this one is, by the way, there's a thing called the A-frame editor that you can drop on your page. It's an extra script, and you can jump out of your experience and into, it's actually based on the 3JS editor. So this is live in the page. He's able to pause the world and inspect all the 3D stuff, which I think is pretty neat. It is gonna, there we go. Can you see again? Shoot the word restart when you can see it. Trying to put splash? Privacy. In what aspects of privacy are you? Yes, you're right. It is on the web. So you're right. That's a very good question. I would say that most of the privacy pitfalls that already exist exist in VR. There are a couple new things you have to worry about. We actually have the ability, an unscrupulous person has the ability to collect extra information about you. For instance, how tall you are, how far apart your eyes are. Technically, you may even be able to, with a little bit of time, if someone's in a VR experience and you're not being nice, collect, obviously the experience on the page or an ad or something would have to be doing this, but you could actually figure out how long your arms are. And that might be enough and that might be information that you could be used, not necessarily, that's not very useful information by itself, but it's really useful to fingerprint you. And it says, oh, the person whose eyes are this far apart and his arms are this long and they're this tall, plus their IP address, I know who that is. And so we are exposing new kinds of privacy-sensitive information to the web, and thus we need to make sure we're safeguarding them. This is definitely a less explored aspect of this. I'm not going to lie to you. However, I suspect that a version of webVR that's going to end up in the world is going to have a permission model. A web page can't just start talking to your headset without your permission. Precisely. And then from there, existing browser privacy features, things like blocking trackers and things that browsers like Firefox are already working on are going to apply. Where it's okay, this VR page also has a bunch of weird tracking scripts on it. Let's be extra careful. But there is a lot of unanswered questions around privacy and security that present themselves in these in sort of the VR space. For instance, let's say I'm wearing a VR headset that has a VR browser, right? Okay, but web pages can create an immersive experience. What's to stop someone from doing the ultimate phishing attack, making an immersive experience that looks like your VR browser, right? Because everything you can see is the web page. There's no sort of outside the web page. So you could make something that looks like your VR operating system, makes it look like your VR browser. With a lot of exploration in place of saying if you're going to make a full VR experience where even navigating between web pages is actually done in VR, how do you give the user a sense of trust as to where they're headed and that the place that they're going is the place they think they're going? Yes, inception. Because yes, there's a very real risk that you could incept someone into believing they're going to a VR place they trust and then doing not nice things to them. Oh, sure. Oh, You can. Well, I'll work back to front. Go ahead. I think we'll never have games, quote, only on the web, but I do think that it's likely that games are going to proliferate on the web. John Carmack of Oculus, famous nerd, maker of Doom, he actually does not like JavaScript very much at all because he's obsessed with absolute byte level performance and he finds JavaScript too sloppy. However, even he recognized multiple times in the early days of webVR, someone sent him a link and was like, check out this game I made. And he was like, being able to click a link and 30 seconds later be playing your game is something that like no one else can compete with. And Facebook has actually been working with something called React VR, which actually is React, but as opposed to describing a web page, you're describing a 3D world using elements. It looks a lot like A-Frame, and in fact, there's actually bindings that let you use A-Frame in React VR. It's very cool. I encourage you to check it out if you're into React. And Carmack is obsessed with React VR, where he's actually like, being able to like make edits to this thing and immediately see my changes in real time is the best. So I do think that a lot of people I think are going to start distributing things on the web. However, we're still, a lot of stuff one of the reasons you don't distribute things on the web is sometimes it's hard to get people to pay. A lot of people know this. But I do think that you're going to see more and more stuff crossing over to the web as the quality of what's possible on the web crosses the threshold of good enough into great. Yes?
Just one quick thing. Yes, you can use React VR. It's not evil and it kind of works. But just to finish the previous question, sorry. But you can also use React with A-Frame. Like A-Frame is framework agnostic. So if you want to use Vue, if you want to use React, if you want to make your own framework, like everybody does every month or so, you can make it. So you can use P-React also. I mean, it's pretty agnostic on this.
Oh, sorry. Go ahead.
Okay. So the service will be over the internet, right? HTTP. So have you considered the security? Because as you said before, it will be vulnerable to phishing attacks or buffer overflow.
I suspect that there's this trend that's happening in modern web APIs, where modern powerful web APIs are by default limited to HTTPS only, with no exceptions. In fact, we actually went back and changed the geolocation API. You can no longer use the web geolocation API ever on a web page that is not HTTPS. Get user media and WebRTC, you must have HTTPS to access those APIs. I suspect webVR is going to be the same. So no matter what you do, it must be an HTTPS website. HTTP not allowed.
Okay, only HTTPS. So.
I suspect that's going to be the way it goes. That is not the current state. These are all very experimental right now. Mm-hmm. I do suspect that the final ship versions are going to be absolutely require secure connections.
Okay.
Which is a good step in the right direction.
Okay, good.
Claypotch? Sure.
I would like to ask about Drupal and how you see this module Drupal VL its future purpose. Like for the simple user to get familiar with VR, or it has a future?
Yeah. So the question was about sort of Drupal and the integration of Drupal into VR stuff into Drupal and letting users have more control with that stuff. I will confess to not being a Drupal expert and sort of.
How it will be the purpose of this module?
The purpose of from what I understand, the purpose of the Drupal VR module is to let people actually start building VR experiences using Drupal UI, which is very cool. I haven't seen that in action, but I think it's a really cool idea. The purpose of Drupal A-Frame is more for sort of the admin side of Drupal, where you can make A-Frame content types and A-Frame view modes and sort of let A-frame elements be first-class Drupal entities.
So the user will upload an image, and it automatically renders to AVR image or something.
I don't know that that's the case, but it would be nice if it had common use case. I would hope that Drupal VR would like common use cases very easy. I want to make a 360 video. I upload a video and I click a button and it automatically makes it. That's what I would hope. And that if I was building it, that's what I would build. But I'm not building it. But I assume if that's not what Drupal VR becomes, that's what something will become because the use case is so strong.
Okay. Yes, if you will.
Yes, sure. Use the microphone right there if you'd like it.
I will not take yours. So I'm not sure for the question, but is it possible to use multi users in the same server?
So the question was about, I think you could all hear it, but the question was about multiplayer and is it possible to have multiple people? The answer is right now it is, but it's hard. Right now, these like the sensors of this device only can detect one headset at a time, which would mean we need a whole second computer right here with a whole second person standing here, which is expensive. And also now you have to send high fidelity, low latency, positional and orientation information over the network. And there are demos that do this. There are demos that let people sort of all walk around in the same space with little avatars. And you know, it's about what you'd expect from a multiplayer online game. It's not that same 90 frames a second perfect fidelity.
If you already know Firebase, you can. There is already a Firebase component.
What?
So yeah, do you know Firebase? Firebase, the database from Google to do some low latency. So you can use Firebase as a component. You can use WebRTC. So there are components already to do networked A-frame experiences.
In addition, when we switch over from sensor-based things to Tango-style devices where we're constantly just building a 3D map, the person standing next to me is building the same 3D map, and we can use like traditional 3D multiplayer to share a space. Hopefully, your avatar is rendered in high quality, because otherwise you're going to run into the other person because they're going to be right there.
I'm using the 3D mapping on a performance that I made with the theatrical script, and I want to use, more actors in the same, visual scale to act, to interact.
Yes.
That's why. What about the sensor and all the project that you must build to have multi users in the same in one performance, maybe in a few.
Sure. So there's a couple ways
years.
you can share an experience.
Yeah.
One is you literally share
because now we have the escape rooms, but it's more.
Yeah. So right
simple.
now, if you want to share an experience, you can't share a physical space, but you can share a virtual space. Yeah. So the other person would be standing right here, and they would be able to be, and they'd be in the same virtual space, but not in the same physical space. When we move away from sensor-based to sort of SLAM-based or augmented reality style sensors, you could both share the same physical space and the same virtual space, which would be very cool for, like you said, for performances and things like that. But right now that's not possible, and both of them will require networking to make the other people visible to you. So you're going to have the same challenges you would have with a 3D game.
I can see this in the game, in the 3D games.
Mm-hmm.
Yes,
but it's very much so in the realm of possibility. And I'm very looking forward to that as well, being able to actually share the same the same room with somebody.
Yeah.
Did you have a comment?
Just quickly, that you can you can use two devices on the same set of. Yes. The only thing is, for example, if I'm playing on the same space as he is, I don't want to punch him. I don't want him to punch me. So what you will. You can do another one. What you will do, for example, you can play tennis or ping pong because you have like a natural route limit in the game. You're never going to cross the net. So you put like another headset, but as you said, you need to be able to afford it, and then you do networking. So you can have two headsets in the same physical space with the same trackers and networked today.
Yeah,
That's fun to watch people.
Thank you. Thank you very much.
Sure. Do you want to blush?
Can we use custom types of sensors, like RFIDs, to walk around and so we can detect something is happening?
So right now, there are not custom sensors, but for instance, with the HTC system, they sell additional sensors. So you can attach additional sensors to other objects, and then you can see that object's position and orientation.
Okay.
So you can do more than just two controllers and a headset. You can do many, many more objects, but you have to put a sensor on each object. Those sensors are linked to this system. It is possible to make your own homebrew sensors. It's not like they're DRM, they're just very complex.
Okay.
It would be nice. I suspect people are going to do some fun hacking and make some more advanced sensors, but it's not quite there yet. Any other questions in the room? Yeah.
Does webVR work on Windows Phone?
I do not know if webVR works on Windows Phone. If it did, it would work over the integrated Edge browser on Windows Phone. However, I suspect that maybe the sort of Google Cardboard level of webVR definitely should work. Windows Phone devices have, a screen and gyroscopes. So the basics of webVR should work. I don't think more immersive things work right now, and I don't know what Microsoft's plans are there. They seem to have stepped back from Windows Phone a little bit. But I don't know if I don't think Patrick's here anymore, so I don't think I can.
We have somebody from Microsoft in the room also.
Oh, is he still in the room?
I don't know if he is. But
I don't see him. There was someone from Microsoft here earlier who probably would have answered that question with far less shrugging. No, they'll be back tomorrow.
Microsoft is pretty involved in the webVR API, so most likely they can't promise, but they're really working on it, so it will probably be supported.
Yeah, sure.
You can shoot at the bullet. Yeah.
What about A-Frame's license?
A-Frame's license is MIT, open source.
Okay, that's fine.
Everything Mozilla does is open source. It's usually, I think it's actually BSD 3 clause or whatever, but it's either that or the Mozilla public license, which is similar to the Apache license. I did. I would love a beer. That would be fantastic. Oh, yeah. Yeah, sure.
And all the experiments also
How easy
made by
is,
Mozilla or
in a
open
few
source,
years
you can check
to make a visual our character in a 3D vision?
A visual was that word visual?
So
you just put it.
In the video calls or with Skype.
Okay. I see what
how
you're
will
saying.
transfer all this? Transforming all
How
this.
in a couple years? I don't know.
Yeah.
So we'd obviously need sensors that would either depends. If you want to have discussions as avatars, as opposed to not our real bodies, you can kind of already do that. WebRTC makes that possible. To use this information we capture plus your voice. People have already built demos of that working. Full body 3D, it's actually scanning your whole body. We're going to need new sensors that don't exist yet. I don't know that I assume that they will exist eventually, but I don't know what the timeline is for that.
Yeah, I watch this, in the movies now, in Hollywood blockbuster the movies, and I think, in a few years maybe
we can all have hologram
we can
conversations.
see all these, yeah.
Bad quality Skype call?
And what about the senses,
I'm going to hope that it just goes down to like a stick figure. A Minecraft person.
Thank you.
Sure.
So you can get yourself scanned in 3D for like 50 euros or so, and you have a low resolution mesh of yourself. Works pretty well. You can then skin it, and then you can animate a mesh of yourself. That's relatively easy.
The good news is that I'm already pretty low resolution, so my scans are pretty efficient.